You claim that cops issue 60 speeding tickets daily. Given the data and a standard deviation, population standard deviation of 13.42, is there enough evidence to reject your claim at alpha is equal to 0.05? Use the p-value method. And then we're also given a little note here that is normally distributed, this data. So we were given the population standard deviation, and we're told it's normally distributed. Therefore, we are going to go with a z-test. So let's go ahead and get into it. Let's write out our null hypothesis, H0. And that's the one that involves equals. So we're saying that the average, when we're claiming this here, we're saying that the average number of tickets they give is 60. So we're going to give 60 per day. The alternative is that the average, that we're wrong, right? That it's not 60. Not necessarily less or more, it's just not 60. So we say, oh no, the mean's not 60. We need to identify our claim. And in this case, we have it right at the beginning. You claim that the cops issue 60 speeding tickets. So this is the rare case, well, at least among the problems that we've been doing, that H0 is actually the claim. So this one's the claim this time, so that'll be fun at the end. All right, so everything else, pretty standard stuff here. Let's get the numbers out of this problem. So we're told sigma is 13.42. We're told the average for the population is 60. And we're told alpha is equal to 0.05. We need n and x bar. N we can find by just counting how many numbers we have here. So we have 1, 2, 3, 4, 5, 16, 19. 19 numbers, and we need x bar. So for this, we're going to go ahead, turn to the calculator. It's just a little more convenient. So we're going to go to stat, edit, and clear a list if there's not already cleared. Go ahead, put all the numbers in. Once you have your numbers in, you can also check that you got n right because the last number will be listed here. So I have like 19, and we got 19, so we counted correctly. It's always wise to go back really quick and just double check it. So I'm going to do that really quick. All right, so everything checks out. This is where the most mistakes happen, so just be really careful right here. So okay, we can go to stat now. We can go to calculate, one var stats. Make sure your list is the list you used. Make sure frequency list is empty and hit calculate. We get out some wonderful stuff here. We get our mean though. That is 60.58. Using this, we can find our test stat, z. Remember the formula is x bar minus the mean over the standard deviation divided by the square root of n. If you don't remember it, you can go look it up. And let's go ahead, let's plug in our values here. So we've got x bar, that is 60.58. The mean is 60. The standard deviation, population standard deviation is 13.42. And I actually want to, yeah, I copied all that right. Okay, cool. Sometimes I write what's here and I miss like something small. So it's always good to kind of just do a quick double check. And n is 19. So let's go ahead and do this. So we're going to do a fraction. Some students do these in separate steps, which is fine. Just takes a few more calculator entries. Depends on your calculator. We're going to do another fraction. If you have a fraction key though, it really simplifies things. So highly recommend getting comfortable with the feature. And then this is 19. You just hit enter. We get out a z-score of 0.18. We'll go to two places. Z-scores on the table only have two values anyways. We can get this same thing using the calculator. Calculator will also give us the p-value for free. So we'll do that, and then I'll show you how to get the p-value using the chart. So we're going to go to stat, tests. You still need to put all the numbers in the calculator. We go to z-test. We give it the data that we typed in. Our average is 60. Our standard deviation is 13.42. So we put that in. Our frequency list is list 1. That's the one we used. Or the list that we used, the data list. Frequency, leave that at 1. And then mu naught is not equals to. Makes sense. And then we hit calculate. So when we calculate, we're going to get a z value of, again, 0.188, da 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 da. If you round to two places, you get 0.19. And for the p-value, you get 0.85. This p-value the calculator gives you, though, is for both tails. Both tails. If we use the chart to find the p-value with just this, we're only going to get one tail. Let me really quick visualize it for you. So if we were to graph this, right, there'd be 0 here. Here's 0.19. it's a two-tailed test. So there's going to be area this way and area this way at negative 0.19 because it's two tails. So we need to account for both of these. So this would give us, if we look this up, this would give us P over 2. So if we go to the chart and look it up, we're going to get P over 2. So let's look this up. We'll look up the negative version because if you do the positive version, you have to do the whole 1 minus thing because of the whole curve. So it's just a few more steps. So we're going to take the negative version and look up 0.19. So let's go ahead, go to 0.19, which is here's 0.1 is right here, and then 9 is way here at the end. So it's this guy right there and right there. So we get, what is this value? Calculator's a bit in the way, but you can see it, 0.42465. That's what we get, 0.42465. This is only half of the curve because, again, it's a two-tailed test. So 0.42465. So if we want all of P, we have to double that. So we're going to take this and double it, 0.42465 multiplied by 2. We get 0.8493, and it rounds to 0.85. So we're going to go ahead and go with that. The chart is not going to be perfectly accurate because it's a chart that doesn't have every value on there. The calculator is a bit more accurate that way. So there we go. We get the same thing though. So that's how you would do it using the chart method. And so now that we have our p-value, we can make our decision. We actually don't need this graph here when we're using the p-value method because we can look right at alpha. So looking at alpha, we could compare this against the whole alpha. So the alpha we have is equal to 0.05. If you're going to use this one, if you use the chart method, you need to divide alpha in half because this is only half of p. So you need half of alpha because it's a two-tailed test. Just so we're clear on that. But since we doubled it, we can look right at the full alpha. And so we notice that 0.85 is definitely bigger than 0.05. That means that P is greater than alpha. This is evidence to do not reject or fail to reject the null hypothesis. The null hypothesis. And now we need to talk about the claim. Now, fail to reject or do not reject the null hypothesis means that we think it's right? We didn't reject it. So we think that the null hypothesis is true. We have evidence to support the fact that it's true via our study versus the alternative. We don't think that's correct. Our study doesn't support it. Our claim, though, is the null hypothesis, which we think is correct. So we would say that there is evidence to support our claim. We have evidence to support it. So there is evidence to support the claim. And this is important. Now, we can't say for certain that it's true because we would need, every cop's data ever in order to be able to talk about the population. And that's going to be hard to do. So all we can do is produce evidence. But we, based on our study of police officers here, we have evidence to support the claim that it's about 60. 60 is about the average that a police officer hands out daily. It's somewhere in that neighborhood. And you would tack that on here. So you would say there is evidence to support the claim that the average amount of speeding tickets given out daily, you see, cops issue 60 speeding tickets daily. That's what you would tack on at the end here to tie it back to the problem. And that is how you do a question like this. If you have any questions about this, feel free to drop a comment, subscribe, and hit that bell icon for future videos. And we'll catch you in another problem.